Hello iCampSA students, once again welcome to this video. In this video we will be doing a grade 12 functions question. So this question covers parabola or quadratic functions, and of course we have a straight line also. Okay, so without wasting any more time, in question 6 we have the graphs of f at x, which is the parabola, and the graph of g at x, which is a straight line. Those two are sketched below, and then we are told that these two graphs, they intersect at D and at B, and also A and B happens to be the x-intercept. Okay, and then we also have point C, which we can say that is the y-intercept for the graph of f, and the point here, which is the y-intercept for the graph of G. Okay, so first question, we are asked to determine the coordinates of A and B, and we already know that A and B are the x-intercepts. So in order to be able to determine the x-intercept, we must set the graph of f to be equals to 0. Okay, so for 6.1 we have the graph of f, which is minus x squared. F at x is equal to minus x squared plus 7x plus 8, and we said for x-intercept, y is equal to 0. Let's go ahead and do so. Let's take this to this side, minus x squared plus 7x plus 8 is equal to 0. Let's divide by -1 throughout. We will have x squared plus, it's supposed to be minus 7x minus 8 is equal to 0. Now let's find the factors of 8, which would give us 7. We'll have x and x, we'll have 8 and 1, and then we are supposed to have minus 8 here and positive 1. Okay, therefore x is equal to -1, or x is equal to 8, or x is equal to 8. Okay, and then from there we can see that the -1 will be the coordinates of A, since it's to the left of the y-axis, and then the 8, it's for B. So let's properly write that. We know that A is -1 and 0, and then B is 8 and 0. So that is your 6.1. And then 6.2, we are asked to calculate A, which is the x coordinates of D. What do we know about D? D is a point of intersection between the parabola and the fx, and the straight line. Okay, so at the point where our graphs intersect, they are also equal. So in order to be able to find the coordinates of D, we are supposed to equate the two graphs. So for 6.2, we will say f at x is equal to g at x at the intersection at the intersection. Okay, so let's quickly write the equation for f at x, which is x squared plus 7x plus 8, and then the one for g at x is minus 3x plus 24. Now let's put everything in one side and solve for x. We have minus x squared plus 7x plus 3x plus 8 minus 24 is equal to 0. Okay, and then from there let's add the like terms, and then we'll divide with negatives. So we'll have minus x squared. 7x plus 3x is what? Is 10x plus 10x, and then positive 8 minus 28 will be minus 16 is equal to 0. And then from here, let's divide with negative to make the first term positive. Minus 10x plus 16 is equal to 0. Now let's see if we're able to solve this by factorizing. So we have to open two brackets, and then we will have x and x, and then what are the factors of 16 that can give us 10? Let's see. We have 8 and 2, and then they have to be both negative. Yes. Okay, so therefore the value of x is equal to 2, or x is equal to 8, or x is equal to 8. Those are answers, and we already know that at one intersection there we have 8, which is B, but we are looking for the D, so for D we now know that A, or maybe let's just say A, is equal to 2. So for D we have A and I think it's B. A and B is okay. Once we are here, let's go to 6.3, and we are told that x, y is a point on the graph of f where x is greater or equal to a, but x is less or equal to 8. We know that 8 is here. So what they mean by that restriction there is that okay, the point sy, we are only considering this graph, or maybe from here to here, we are only considering that portion. Okay, so SC is drawn parallel to the y-axis with t on the graph, and then we are asked to determine the ST in terms of x. So we know already that xt, first thing first, is a vertical line. So when we're calculating the length of a vertical line, which is what we are asked here, we are simply going to subtract the y values, or the y coordinates of these 2 points, the s and the t. Okay, but since we don't have the direct values of s and we don't have the direct values of t, we will just use the equations, because both of these terms lie on the graphs respectively. So if we want to find the distance st, we must say what? The graph of f is above the one of t, so we say f at x minus g at x, the graph of g, and then we will find st. Okay, and we are asked to find it in terms of x, so let's go ahead and do that. We have 6.3 now. 6.3 st is equal to f at x minus g at x. Okay, and then for f at x, what is our equation? Is minus x squared plus 7x plus 8, minus x squared plus 7x plus 8, and then for g at x we have minus 3x plus 24, minus 3x plus 24. Yes, so let's put that in brackets, minus 3x plus 24. Okay, and then let's simplify. We'll have x squared plus 7x plus 3x plus 8 minus 24, and this happens to be minus x squared plus 10x minus 16 minus 16. This is the length ST in terms of s, sorry, in terms of x. This is the length ST, and then next we have to calculate the maximum length of ST. So the maximum length of ST will be or will occur at the point whereby these two graphs, the straight line and the parabola, are the furthest away from each other, and remember that the equation that we have just calculated, or we've just wrote here for ST, is to calculate any distance between these two graphs, any length between these two graphs, just like that red line as I've drawn here. So any length between these two graphs can be calculated by that formula or equation we've just calculated for ST. But now, to find the maximum value of the length ST, we must understand that the graph of the quadratic function will be the furthest away from the that point, or that maximum length will occur where? At the turning point of this equation that we have just derived here, which is the equation of the length or the space between these two functions. So the maximum distance will occur at what? At the turning point. So we need to calculate the turning point of this, and then firstly the x coordinates, and then we will substitute the x coordinates, which would give us the maximum length ST. Let's quickly do this and find the turning point of this equation. So we have 6.4 is equal to we are looking for the turning point first. We'll use the vertex formula, which is x is equal to minus b over 2a. So our b there is what? Is 10. We'll have minus 10 over 2 times negative 1. So negative divided by negative is positive. 10 divided by 2 will be 5. That is the value of x, where the maximum length of ST will occur. So we have the x coordinate. Now we can go to our equation of ST to find the maximum length of ST. So we'll say ST max is equal to minus 5 squared plus 10 times 5 minus 16. So we will have minus 25 plus 50 minus 16 So minus 25 plus 50 is positive 25. So 25 minus 16, that should be 9 units. 9 units. That's the maximum length. It's 9 units. Okay, it will be 9 units, and that marks the end of this video. Thank you for watching. Don't forget to subscribe, like, and comment, and share with others. And good luck with your studies.